Hi everyone, this is Fahad Mirza and I welcome you to the channel. Let me show you first something interesting. This is AlphaMaze. On the right hand side, I'm just clicking on this blue button to create a maze configuration, and then I'm clicking on this play icon here, and you will see that now this AI is generating the solution, and on the left hand side it is solving this puzzle. You can randomly select any other, and then this model AlphaMaze is solving this visual puzzle quite easily. And in this video we are going to install this AlphaMaze on our local system, and then we will see how it works. Let's talk a bit more about this model, as seems quite interesting. So primarily what this model is doing, it is enabling the text-based LLMs to think visually. This model has been trained by using supervised fine tuning in the first stage, and then the GRPO, which we already have covered on the channel in great detail, which is primarily the, I would say, the cornerstone of DeepSeek R1 model, which has really brought a lot of excitement among the AI community. AlphaMaze is a decoder only model that has been trained to think visually by solving maze puzzles, which really are hard for the LLMs to solve. Humans find it quite intuitive to solve mazes, but for LLMs it is not that easy, because language models or LLMs are really good at words, but when it comes to visual spatial reasoning, they struggle a lot, and that is where this model AlphaMaze is trying to help. As I said, they have trained it in two steps. First, they did the supervised fine tuning, where they taught the model to predict each move, and then they used this group relative policy optimization, or GRPO, for improved decision making and reasoning. Now, interestingly enough, according to their training details, once they took the instruction tuned model and then they used SFT, model became 86% accurate, and then in the second phase they used GRPO, which made this model 93% accurate and stronger self correction. If a model can see spatial relationship from text, it really opens up a lot of possibilities for robotics, navigation, and other tasks that need visual and sequential reasoning. So now I hope that you understand a bit more about this model. Let's try to get it installed. Before that, let me also give a huge shout out to Mast Compute, who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description with a discount coupon of 50% for a range of GPUs. This is my Ubuntu system, and this is my GPU card, NVIDIA RTX 6000 with 48 GB of VRAM. As usual, let's start by creating a virtual environment. And next up, I'm installing all the prerequisites, which include torch and transformers and some other stuff. And also I'm launching my Jupyter notebooks, and then we will launch our model there. Now, one thing I'm doing here, I'm also installing flash attention. If your GPU supports it, then I would highly recommend you do it. If not, then you can skip the flash attention line from here. Okay, let's download the model first. And we are simply using this transformers library. And the model is being downloaded. And you can see that there is only one shard. While it downloads it, let's talk a bit about its training. So this was trained using a combination of supervised fine tuning and reinforcement learning with GRPO. The base model was the distilled 1.5 billion parameter Quen model based on DeepSeek R1, and the model was fine tuned on a data set of around 100,000 maze examples. The training data consisted of text based maze representation. So first it was, as I said, it was trained to predict the solution path step by step. After SFT, the model was further trained using reinforcement learning with GRPO, and the reward function was designed to encourage correct solution, valid movement tokens, and proper formatting. The model was then trained for 1000 steps using a single NVIDIA A6000 GPU, the one which I am using. How impressive that is. So really, really cool stuff. Okay, now before so model is loaded, before we move forward, let me also give a huge thanks to the sponsors of the video, who are iGenbot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will also drop the link to their website in videos description. Okay, so let's go back and check out our model. So the model is loaded, and now let's do the inference. For inference, I am just going to give it this maze. So if I just break it down, you will see that this whole prompt is simply some tokens which are specifying some of the maze coordinates, like what are the rows and all that stuff. It is then also specifying the target, it is specifying the movement, it is specifying the origin, and then a long prompt which I'm just breaking it down for you to check out. It is thinking step by step, and that is what we wanted to do. Hopefully that this breaking would not impact it. So there is a lot of stuff. The whole maze has been put it in one text prompt. So this is a whole prompt, and then we are passing it out the prompt template, and we are using tokenizer to tokenize it, and then model is generating the output on the basis of these hyperparameters, and then model is going to print how it is going to solve the maze. Of course, it we can't really display the whole stuff because that is going to be a lot of thinking, but still it should show us a glimpse of how it thinks step by step in the solution in order to solve the puzzle. So I'm going to run it, and we are also going to check out the VRAM consumption here, which is just around 4 gig. It's a very lightweight one, and there you go. It has started solving the maze, and then it is thinking, and then it is giving us go right, go left, and all that stuff. So it is quite interesting that how it is going through this maze, the LLM. There is no vision model involved here, and I'm not sure how they have created this GUI on top of it. I couldn't find any link or any sort of code to display or run this locally. I don't think so. They have made it public yet. But other than that, I think pretty neat, I would say. As you can see that they are also displaying it here, the solution which we saw. So pretty interesting, and try it out. Let me know what do you think about this maze solution. Interestingly enough, I also tried the same maze question with OpenAI's O1. It also passed it with flying colors, by the way. So we just have to be fair here. Yes, DeepSeek's R1's distilled one reasoning is quite good, and even after when they fine tuned it, it is solving it. But at the same time, OpenAI's O1 didn't struggle, and it also gave me the correct answer in terms of text, of course. So that's it. Let me know what you think about this AlphaMaze, which has been fine tuned with the help of OneSloth. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.